Hello, this is John. This is my Intro to Robotics Midterm exam. In Objective 1, we are using a temperature sensor to display the temperature of the room and control a motor. Here in this objective, you can see I'm using the constant integer to set that the temperature sensor is on analog pin 0. I set the threshold to 70 degrees, and then my potentiometer is going to be on analog pin 1. And here this is just setting my digital pin 9 to an output, and here is just stating that it's going to be whatever we have down here is going to be printed into the serial monitor. Here I'm just floating the values of these integers because they're not going to be just whole numbers, they're going to be decimals. And here's just the figuring out of the numbers based off of the temperature sensor. Here it's going to just put out voltage and then the voltage in the serial monitor, and then on the same line degrees in Celsius, and then on the same line degrees in Fahrenheit, and then it'll go down another line. Then here it is just reading the value of the potentiometer to set the motor speed. And then the if-else statement here is going to say if degrees in Fahrenheit is greater than the threshold, then the motor will turn on at the speed that is set by the potentiometer. And if it is not, if degrees in Fahrenheit is not higher than the threshold, then the motor will not turn on. And here is the serial monitor of the temperatures. As you can see, when I put my hand on the temperature sensor, the temperature goes up.
Alright, so here we have a potentiometer, the temperature sensor, a diode, and a MOSFET. And when the temperature sensor is reading above 70 degrees, the DC motor will turn on and the potentiometer adjusts the speed of the motor.
We are using a liquid crystal display to display hello world and the value of a potentiometer. Here I'm using this code to display on the liquid crystal display. This here I'm just including the library for the liquid crystal display. And up here I'm just stating that the potentiometer is in analog pin 0. Then down here I'm just stating on what size the LCD is, clearing what was previously on the LCD. And here I told it on the first line to print on hello world. Down here I'm setting this integer pot equal to whatever the pot value is, and this is setting the cruiser to the first bit on the bottom word. And then this line here, I'm telling it to print starting at this bit whatever the pot value is, and it'll do this every 1/10 of a second.
Here, using the LCD screen and a potentiometer, I am reading the potentiometer value on the LCD, and it adjusts to the value of the potentiometer.
objective 3, we are using the LCD to print out the temperature of the room. So here for objective 3, I am including the LCD library. Then up here I am setting that the temperature sensor will always be on pin 0. Here I am stating all the pins that I am using for the LCD. This is stating at the size, the number of bits and words of the LCD. This is clearing anything previously on the LCD. And here I am printing the word temperature on the first word. Here I am floating the values of voltage degrees Celsius and degrees Fahrenheit. And then my calculations to get what I need. And here I'm setting the cursor to the bottom row of the LCD and then printing the degrees in Fahrenheit and then setting my cursor to the end of the temperature so I can print the letter F to show that it is in Fahrenheit, and it will update every second.
Here, using the LCD screen, the temperature sensor, you can see the temperature displayed on the LCD screen, and you can see when I touch the temperature sensor, the temperature will rise.
For objective 4, I'm using my VEX shield, 2 VEX push buttons, a VEX potentiometer, and a VEX DC motor. When the forward push button is pressed, the motor will rotate clockwise. When the reverse push button is pressed, the motor will rotate counterclockwise. When both push buttons are pressed, the motor will stop. When no push buttons are pressed, the motor will stop. The speed of the rotation will. So in this code, I included the servo library, and here I'm just including the servo and saying that it's a DC motor. I'm attaching DC motor to motor pin 10 on my VEX shield, and then I'm using pin 7 of the digital pins for my forward push button, and then pin 4 as my reverse push button. Down here I am setting the pot value for the pin 0 for the analog pins. Here I'm stating that for the pot values from 0 to 1023 will be equal to 90 to 140, which will cause the motor to turn clockwise. For motor reverse, I'm setting the pot value from 0 to 1023, 0, and making it 0 to 90, making the motor turn counterclockwise. And this is just saying that push button forward, we would read what's on digital pin 7, and for push button reverse, I'm reading the digital pin 4. I have a few if-else statements here. If for this first one, it's stating that if both push buttons are pressed, that the motor will not turn on. This one is stating that if my push button forward is pressed, my motor is going to turn clockwise. Then this one is stating that if push button reverse is pressed, that my motor will turn counterclockwise. And this last one, I'm stating that if nothing is done, no push buttons pressed, then my motor does not turn.
Okay, here using the shield, 2 VEX push buttons, and a VEX DC motor, we will press either one of these buttons and it'll go forward or reverse. And if you press both of them, nothing happens. And if you press one, it goes one way.